Hi, and welcome to Failurology, a podcast about engineering failures. I'm your host, Nicole.
And I'm Brian, and we're both from Calgary, Alberta, Canada.
Thank you again to our Patreon subscribers. For less than the cost of a cup of coffee, you can hear us talk about more interesting engineering failures.
And a whole bunch of side tangents you didn't even know you were interested in.
Especially about trains. We really like trains.
And planes.
And planes, yeah. Brian likes planes. We both like trains.
And maybe you like automobiles.
That's probably true. Anyways.
All right. In place of the engineering news, we're going to talk about a disaster that happened 32 years ago in Montreal at E'cole Polytechnique, which is known as the E'cole Polytechnique Massacre, or the Montreal Massacre. The Montreal Massacre was an anti-feminist mass shooting in Montreal at an engineering school affiliated with the Université de Montréal, where 14 women were murdered and 10 women and 4 men were injured.
While there have been some debates over various interpretations of the events, their significance, and the shooter's motives, many, myself included, see this as a wider societal attack against women. There are other factors, such as the shooter's abuse as a child, that could be to blame, but the fact that he singled out all of the women in the mechanical engineering class by asking the women to step to one side and the men to step to the other, which, by the way, based on the numbers, the women represented 18% of this mechanical engineering class. To me, that sends a pretty clear message that this was an attack against women, and that's really just not cool. So we wanted to, with this massacre happening on December 6th, the day after this episode comes out, we just wanted to take a moment to pay respect to all of the women and men who lost their lives that day or who were impacted by this massacre.
Yeah, and when people are going to school, it shouldn't be a place that they fear violence or gun violence or segregation. This shouldn't be something that happens at a place of learning or really anywhere else. And this substantially impacted gun policy in Canada, I think overall for the positive. So this led to more stringent gun control laws in Canada. It also introduced changes in the tactical response of how police responded to shooting incidents. And some of these changes that happened as a result of the Montreal Massacre, they were later credited with minimizing casualties during the Dawson College shooting, which happened a number of years later here in Canada. No matter what your beliefs are or your belief system, if you reach a point in your beliefs or in your life where you feel that violence is a solution and bringing a gun somewhere where you intentionally intend to harm people or use a gun in a threatening manner or even just threaten other people, it's like it might be time to just rethink some of those beliefs or that philosophy that you have. So unfortunately, this did lead to significant loss of life and injuries to people that had a prolonged impact. It impacted not only their families, but their friends, and it cut short a lot of very young lives that could have gone on to do great things in society or build families or have really positive interactions. So the acts of this one person cut that short for a lot of people.
Agreed.
This week's episode of Failurology is brought to you by CRISPR. Not the genetic engineering technique, but your vegetable CRISPR.
Actually, this isn't a sponsor. It's a PSA. You should probably clean out your vegetable CRISPR. There's definitely a cucumber or a box of mixed greens you bought last week or last month or last year that needs to go.
We're not here to judge. We can't see your fridge. We won't even know whether you cleaned it out or not, but you'll probably feel better if you do.
Now on to this week's engineering failure, the Charles de Gaulle airport collapse in Paris, France. Terminal 2 at Charles de Gaulle was a futuristic-looking elliptical tube constructed of concrete rings. It was designed by Paul Andrew, who also designed the French terminal for the English Channel Tunnel, which we talked about in episode 20. Interestingly enough, Andrew had spent most of his career working on airport designs, and he'd been working at Charles de Gaulle since about 1974, so he had kind of made his career at this airport. For the terminal design, he drew upon the principles for tunnel construction to design a space with no internal supports. This would allow passengers to move easily through the terminal. As there were no internal supports, the outer shell of the building supported its loads. So that outer shell of the building became structure, the skeleton of the building with nothing in the middle.
Yeah, and this is a really, really cool looking airport design. There's no big pillars in the way. There's no, cross members that are taking any of the supporting loads. So it's a very open terminal concept. And if you've ever traveled through Charles de Gaulle, I think it's a really neat looking airport on the inside. And part of that was, this design concept that he had in mind, this open airport concept.
Very cool. Andre retired in 2003, and this terminal was likely one of his last projects. He's been cited as an example of, quote, architectural hubris, and you'll see why when we finish this episode. A large chunk of Terminal 2E near Gate E50 crashed down in the early morning hours of May 23, 2004. I believe the collapse occurred sometime around 7 a.m. 4 people were killed and many more were injured, and this collapse occurred less than a year after opening. 11 months to be exact from the date that the terminal opened.
That's not really good. Your building should not collapse, well, really ever, but it certainly shouldn't collapse, in under a year of it being opened.
Yeah, that's pretty bad. Flights from Johannesburg and Newark were offloading. At the time of the collapse, a flight to Prague was boarding. 90 minutes before total failure, a strip of concrete fell from the underside of the terminal's shell structure. Then the north wall buckled and the struts supporting the glass pierced through the concrete shell. Then the edge beam of the ceiling collapsed. Passengers saw concrete dust falling and fissures in the roof. This is something interesting, and I don't know if you read when you were researching, Brian, but to me it's interesting that concrete fell from the roof about 90 minutes before the full collapse, and they didn't close the terminal. I don't quite understand why they didn't close it.
I don't have an answer for why they didn't close it. Obviously, I wasn't there at the time. I mean, maybe it was a very small piece of concrete, or it wasn't reported to the proper people, or maybe I guess passengers saw it. I would hope that they reported it, but maybe it was one of those kind of post incident things where the terminal collapses, all these things happen, and then in ensuing interviews with witnesses, the passengers mentioned that they did see concrete falling out of a building. I would think that any time that there's something falling from the ceiling, certainly concrete falling from the ceiling, that's something that should be of concern, that should be reported immediately.
Exactly. That's why I'm confused. To me, I mean, the collapse wasn't preventable. The collapse was inevitable, and we're going to get into that. But any injuries or, loss of life, to me, I mean, if I only saw the concrete collapsing 90 minutes before in one of the articles that I read. And so maybe that's not completely accurate. I didn't see it noted through several sources. I will say that. But to me, if something falls off the ceiling, especially the concrete 90 minutes before, you'd clear the space.
Yeah, just like the TSA saying, see something, say something, right?
Yeah,
Terminal 2E at Charles de Gaulle Airport, it consisted of a main passenger building, a concourse that ran parallel to it, and an isthmus connecting the two buildings together. So in a section view, the terminal looked like a deformed tube resting on the flattest side. So if you take a roll of toilet paper or a wrapping paper roll and you squish it down a little bit, that's the shape, the profile shape that the terminal building had. So the roof was made of 10 sections. They were all separated by glazed strips, and each section in the roof was further divided into 4-meter long bays. The vault supports for each bay were 30 centimeters thick, so fairly thick. They were precast, perforated, and reinforced concrete rings. And the entire tube was enclosed in glass with an external steel tension truss system between the concrete and the glass. To compensate for thermal and other forces, the roof wasn't fixed rigidly to its support. So similar like a bridge, there was some ability for the roof to move as it warmed up during the day or cooled off during the night. And the trusses were supposed to be compressed between the glass and the concrete. It's believed that they pierced the concrete, which weakened the connections and also the concrete itself. To stiffen the shell of vault, curved steel girders brace the two sides. The tensile girders are held away from the vault by regularly spaced steel struts on 20 centimeter diameter plates, which are embedded in 10 centimeter deep recesses. There'll be pictures of all of this on the website. Where 3 elevated walkways enter the concourse at the 20-meter long collapse area, the lower portion of the 3 sections of shell were omitted for footbridge access. Steel connections transferred loads from the shortened shell to the full-length ones on either side. As part of the report that we'll get into in a little bit here, where the 3 elevated walkways enter the concourse, this is likely one of the causes of failure or one of the contributing factors for why the terminal collapsed in the way that it did.
So the collapse of this 33-meter section, like I mentioned, killed 4 people and it injured 3 others. And it also left a 50-meter by 30-meter hole in the tubular design of the terminal. There was an official investigation, and the report pointed to design flaws and oversights in construction as contributing factors to the collapse. So a lot of the flaws or oversights, they're broken down into 2 different types. There's process failure and structural failure. Process being, how the project was set up, how decisions were made, how the project was managed, how the construction was managed, that type of thing. So I'm going to cover those first, and then Brian's going to tell you about the structural failures. So first, there was a lack of detailed analysis and inadequate design checking, which allowed the construction of a poorly engineered structure. So essentially, the group that was in charge of designing and constructing this airport, they weren't really overseen by any other parties. There was no peer review, no design review. I don't really even think they were overseeing standards. They were kind of left to do their own thing, and no one was really watching what they were doing and whether or not they were following rules and making sure that the designs were safe. As well, the external structure was chosen based on aesthetic appeal rather than calculated engineering judgment. You've probably heard about this in episode 32 when we talked about the Big O Stadium in Montreal. It suffered a similar fate. It was also designed for an aesthetic choice and seemed like very little thought went into how that aesthetic choice would be constructed and how it would function, and it didn't really function very well because the roof keeps collapsing.
Yeah, these have a lot of similarities between the Big O Stadium in Montreal and Charles de Gaulle Airport. Aesthetically, they both look super, super cool. Execution on the construction side, and I guess pre-construction stuff on the design side, not probably as good as what it should have been.
And I'm just going to say it, both of those cases had France architects. I'm just going to say it. I'm not saying that France doesn't have good engineers and architects. I'm sure they have great ones. But these 2 examples have a common denominator, and that's that both architects are from France and that both of these structures failed. So as I mentioned, the architects and engineers, they were from a state-owned group called Aéroports de Paris, and they designed the building and managed construction. And again, there was no distinction between the client and the architect. So they were judge and jury. No one was overseeing them. And honestly, it's not really a surprise that corners were cut for a more cost-effective design, so cost saving, or for a more prestigious look. They really wanted that aesthetic to set them apart from all of the other airports.
Yeah, it's always tricky working on projects where the owner and the engineering company are the same. There's not a lot of pushback on either side, and it's not the greatest relationship to have between the 2 parties.
It's also tricky when the owner and the general contractor are the same. I experienced that quite a bit. We see a lot of developers basically do self-construction. Some of them are great at it. I'm definitely not saying it's a horrible idea. Like some developers are fantastic at it, and some are a little less organized and constantly asking questions about, can I change this? Can I do this? Can I change that? No, you can't. We need that. That's important. In this case, though, at Charles de Gaulle, the construction company worked as close to the limits as possible so that they could reduce costs. So they tried to limit the safety factors as much as possible, cut corners wherever they could, just to keep costs down as much as possible. And the process for this construction project made it possible to avoid competition, because the architecture firm was state-owned and they designed the building, they managed the construction. So they kind of had full say in who was hired to do the work. And there was also pressure from the airport to ensure that a French airport would be designed by a French architect, which is also what we saw happen at the Big O. Quebec is very big on having French representation in a lot of their projects. And again, I'm not saying there are great French architects, but that's one of the big reasons that they had the architect that they had on the Big O, was because he was French and he had the same aesthetic and the same vision that they wanted to see. And it just wasn't a really well thought out design. Same as here.
Yeah, sometimes it's important just to step back from projects a little bit and appreciate them on a larger level, or at least think about them on a larger level. Because a lot of these things do contribute to failures that we've talked about, or issues later on in the design or construction process. In addition to the process failures that Nicole just talked about, the inquiry found some structural engineering failures, and the investigation identified 2 possible failure modes. So the first one, there's overstress of some external struts on the north side of the footbridge openings. The load applied was 4.5 times greater than the maximum permissible load, which is fairly significant. And
It's a
the
lot.
fracturing, that is a lot. And the second possible failure mode that they found was the fracturing of the shell's edge beam on the south side led to the shell falling off its bearings to the ground. So both these things, not ideal to be happening.
No.
In addition, there were a number of contributing factors that may not have led to the cause on the day of the failure, but would have certainly contributed to failure at some point.
Yeah, so one thing that kept coming up for me doing all this research was that, there were things that caused the failure on the day of the failure, but there was a ton of other factors that would have caused a failure kind of at any point. And so the failure was pretty much inevitable from what I've read.
Yeah, so if this didn't fail on the day and the time that it failed, there could have been significantly more fatalities or injuries that happened as a result of this. If there was, a lot of flights coming in or departing when people are deplaning and trying to onboard planes at the same time. It's never good when buildings collapse. It's certainly not good when building collapses, injure and kill people, but this could have happened at a much worse time.
Yeah, great point. Because it happened at 7:00 in the morning, the airport was mostly empty. And so, the amount of people directly impacted by the collapse was smaller than it would have been if this happened at a peak time. This could have been really, really bad. I mean, it's already really bad, but it could have been a lot more reallys in front of the bad. So really, really, really bad.
Yes. So like I mentioned, there were a number of other contributing factors that may not have led to this immediate cause of failure, but would have likely led to failure in the future. So the concrete roof shell, it was inherently weak. The building was not designed to support the stress it was put under, and the concrete creep and fatigue caused by cyclical loading accelerated the failure. Secondly, variations in temperature were not anticipated during the design phase. In the days leading up to the collapse, the temperatures at the airport, they ranged from 4 degrees Celsius to 20 degrees Celsius, which led to additional stress on the bridge shell.
This is pretty significant to me. We've seen some collapses. So when we did the Westgate Bridge failure, when researching that failure, there were 4 or 5 other bridge failures that were of similar bridge design to the Westgate Bridge that also failed. There was a 4 or 5 year period where all of these box girder bridges were collapsing. And a lot of the causes of those failures were due to temperature fluctuation. Of course, not all. There was some pretty big misunderstandings about the limitations and design concepts of the box girder bridges that led to the failures, but some of them had some serious expansion issues that would push the sections of the bridge off of their piers during construction. So that's pretty significant. I also want to say it's always really interesting. So in Calgary, we get swings 4 to 20 degrees Celsius is child's play as far as what we see in Calgary.
That could literally be a couple hours in the afternoon.
Yeah, easily. You could get that from going from the shade to the sun, honestly. But we get temperature swings from, sometimes we'll go from -20 to +10 in a 24 or 36 hour period. And if you don't live here and you're not used to it, that's a lot to account for. And so I think that's a really important part of the design to account for such temperature swings. Also, I do think that, and this always amuses me, but it's really interesting when we have designers who are not from Calgary who come here and they're not used to designing for -40, because we see -40, for several days in the winter, as well as, a lot of Alberta or all of Alberta and a lot of Saskatchewan and Manitoba as well. But if you're not used to designing for -40, you can make some pretty big messes with freezing and leaks and stuff. So temperature is a big part of structural design and mechanical design for that matter.
Yeah, so in Calgary, like Nicole mentioned, we can see these huge temperature fluctuations typically during the winter. So Calgary's on the eastern slopes of the Rocky Mountains. And what happens in the winter is we get a whole bunch of air that comes from the Pacific, and it descends very quickly on the eastern slopes of the Rockies. And as the air descends, it compresses quite a bit, and we'll see these huge spikes in temperature, usually in the course of a number of hours or through the day. So we can have a minus 20 or minus 25 degrees Celsius temperature in the morning, which is fairly cold. And then by mid-afternoon, the temperature will be up to plus 15 degrees Celsius. So things will start to melt. All the snow that we have on the sides of the roads or in the parks, all of that will melt. There'll be water in the streets. So it's great if you don't get migraines. It's great in the middle of winter when you can wear a jacket that you would wear in the summer or the spring. And it provides a little bit of relief during the cold temperatures of the winter.
Do you get Chinook migraines?
I do not get Chinook migraines.
Me either. We're lucky.
I'm a specimen of physical health.
Same. I also want to say this. Leonardo DiCaprio came here and he said that Chinooks were climate change. And I would just like to say that they're not. Climate change is real. Don't get me wrong. I believe in climate change, but Chinooks are different. And they're also kind of fun to get a break from really, really cold winter in the middle of January.
Yeah, and we usually get really sunny skies and it's bright out. And in January, it almost feels like it is April.
Yes.
And then we realize we have another 4 months of winter to go.
Yeah, we just have 2 seasons, winter and road construction. And Chinooks, I guess. So maybe 3 seasons.
But the Chinook season is not long enough to get into road construction.
No, it's not. It's like a day or 2.
That's our sales pitch for moving to Calgary.
Yeah, do it. The winter's not that bad.
Calgary is actually one of the sunniest cities in all of Canada.
Yeah, I think Medicine Hat has the official title, but we are the sunniest of all of the major cities. And we also have mostly affordable housing.
Compared to Vancouver and Toronto.
Yeah.
And New York and San Francisco. And London
and
for our international listeners.
Relatively speaking, as far as large cities go. Mostly affordable housing, reasonable winters with Chinooks, lots of green space. It's a pretty good city.
$500,000 will get you a nice house with a yard if you're in the whole buying a house thing. And the commutes are very reasonable.
Yeah, my commute's only 15 minutes, although I complain that it's too long. It's not that long. It's like 10 kilometers.
I would vote the same commute. It's pretty ideal.
Yeah.
Not quite as good as being able to walk to work, but I'll take it. I think I have a 12-minute commute.
Yeah, that's not bad.
I almost ride my bike there as fast.
It takes me a little bit longer to ride my bike. But on the way there, it's all downhill, so I mostly just coast in the morning, which is kind of nice. The way back's not as much fun. There's a lot more hills coming back, so that's unfortunate.
You just need to get a ride back home from somebody at work, and then you're set.
Seems like cheating.
All right, we should probably... As mentioned earlier, the metal struts connecting the concrete and the glass had pierced through the concrete, which caused cracks and openings on the concrete structure. And fourthly, the connecting walkways into the side of the terminal created additional strain to the structure. So all 4 of these things may not have directly contributed this time, but eventually they would have contributed to a significant failure of this structure.
Yeah, definitely. Like I said, the collapse was inevitable. It was really just a matter of when. Based on the amount of potential causes to this failure, I'm kind of surprised it lasted as long as it did.
11 months is not very long for a building to last.
No, I know, but when you look at how many things were an issue and how many flaws there were in the design, I'm surprised it didn't collapse before then. I mean, this could have collapsed before it was even finished.
I'm actually surprised it made it all the way to the construction stage without additional reinforcements or additional structural issues being addressed on this project, reinforcements added to things.
Yeah, that's why it's important to do peer review. And also, I wonder, and I didn't really come across this when I was researching, but I wonder if the contractor pushed back on anything and said, I don't think this will work, or I don't think that'll work. And the engineers or the architect were like, no, just build it like it's drawn. I don't know if that happened. I'm just curious because contractors are not shy about telling you when they think your design is stupid. And when they tell you, listen to them and check it, please. But they are not shy. And so I'm surprised that they didn't say anything about any of the issues that we've kind of been talking about.
Yeah, so one of the reasons why it's important to run stuff through finite element analysis. It's a great tool if you have access to it for modeling potential issues with designs and structural loads and stress analysis, which is beyond the scope of this podcast.
Definitely. There was a lot of finite element analysis done on this, though. If you're interested, if you want to read more, go check out the links on our website. There's a page for this episode. Our website is failureology.ca. We've got all our links in there, and there's a lot more information about finite element analysis if you want to read more on that.
Yeah, unfortunately, a lot of the FEA that was done was post-incident and not pre-incident, or at least the stuff that we could find. So hopefully this contributed later on to better engineering designs. It's just unfortunate that a really cool building had to collapse and a number of people lost their lives and were injured in this.
Yeah, I think I hope when stuff like this happens, it's eye-opening for people that are building similar buildings or similar designs to take a second and look at what they're actually building or actually designing and make sure that they're checking. You know, I don't want to paint all engineers with the same brush, but there is sometimes a level of arrogance that they can't be wrong, and that, you know, when someone's doing a peer review on their design, it's because their design is bad. And, you know, and the industry can be fairly competitive as well. But peer reviews are a good thing. They protect people. Having an extra set of eyes on something is really a really good idea. And it's how you prevent, you know, mistakes from making it all the way through to construction. It's almost impossible to design something without making a single mistake. You're going to make some kind of mistake somewhere. And so by having another set of eyes,
whether it's an oversight on something or something you didn't fully consider, or you did something one way and there might be a better way to do things. Yeah, peer review is never a bad thing. At least it shouldn't be a bad thing. And it's a really, like Nicole said, it's a really important part of the engineering design process.
Yeah. So after the collapse, they had to bring in a 300-ton crane to lift off the heavy slabs of concrete and rescue the trapped passengers underneath. When it happened, the investigators had really no idea what was going on. They didn't know what the cause was. So they were kind of dealing with terrorism or maybe a bomb or potentially structural failure. We know now that it was structural failure, but at the time they really had no idea. And so they were kind of, you know, approaching this from a ton of different angles to make sure that there weren't going to be issues elsewhere in the airport and that, you know, the people investigating them were safe. And so that would have been, I think that would have presented a really big challenge to investigators at the time. A French court ultimately found the Paris airport operators guilty of involuntary manslaughter as a result of this collapse. And they had to pay 225,000 euros in fines. As well, the general contractor, glass and concrete contractors, as well as the engineering and inspection firms also had to pay fines, and those were somewhere around 100,000 to 150,000 euros. So some pretty hefty fines were given out for this collapse, which honestly I like to see. That tells me that, you know, the investigation was taken seriously. They're reprimanding the parties that are guilty of this failure. I think this is a really good thing that they did. You know, silver lining, I guess. On March 17th, 2005, so almost a year later, it was decided that the whole part of Terminal 2E that collapsed would be rebuilt, and that project cost about 100 million euros. The tube-style structure was replaced with a more traditional steel and glass structure. In order for them to do this, they had to build 2 temporary lounges to replicate the capacity while they were rebuilding. So they still needed the capacity of that terminal that they no longer had access to. And so they had to build 2 temporary lounges to basically house passengers while they rebuilt this section of the airport. And this terminal reopened on March 30th, 2008. So almost 4 years after the collapse, which is pretty substantial. It's a pretty big interruption. New York Times reporter Christopher Hawthorne said, quote, "It is in translating the design from one office to the next that mistakes are amplified and become deadly," end quote. So as we've been talking about, file sharing, either PDF drawings or BIM models, which is building information models, peer review, and overlapping site reviews can help prevent future failures from occurring. And remember, as I always say, when someone says your design sucks, check it. It only takes a few minutes or maybe a few hours, but it could save lives, and it's probably going to save a lot of money and a lot of headache and embarrassment later when you just didn't listen.
So there you have it, the collapse of the Charles de Gaulle Airport Terminal. A number of factors from design to construction to costs led to the collapse of a brand new terminal in under a year after it opened. Engineers know better than anyone else how their designs can fail, or at least you should. And it's up to us to raise the flag and voice our concerns before failure occurs. Public safety depends on good engineering design, good engineering decisions, and good engineering oversight.
For photos, sources, and an episode summary from this week's episode, head to failurology.ca. If you're enjoying what you're hearing, please rate, review, and subscribe to Failurology so more people can find us. If you want to chat with us, our Twitter handle is @Failurology. You can email us at thefailurologypodcast@gmail.com. You can connect with us on LinkedIn, or you can check out our Patreon page with access to bonus episodes about many, many interesting things. Check out the show notes for links to all of these. Thanks everyone for listening, and tune into the next episode for a special preview of 2 of our favorite mini failure episodes to date. Bye everyone. Talk soon.